Good day, everybody. I wanted to go through our very first review or scrimmage for Chapter 6 here, and this will go through each answer. So take time on your own to go through it, but as you have any questions or issues, don't hesitate to try to watch this to get some answers. All right. So let's start off with our first question here. For each polygon below, determine whether it's regular or non-regular. Now, we spoke about this in our learning target for 6A. A regular polygon, it has all congruent sides and congruent angles. Okay, so for it to be regular, it's got to have congruent sides and congruent angles. If we take a look at the first one, does it have congruent sides, congruent angles? Definitely not congruent sides, long, short, things like that. But more importantly, we could say maybe they're just a bad artist. There's no symbols that say that these are congruent. So this is non-regular. This one, take a look. We got all congruent sides, so that's our first requirement taken care of. What about all congruent angles? 1, 2, 3, 4, 5, 6. All congruent angles, this is regular. Okay, this one has all congruent sides, so we're doing pretty good for the first requirement, but are the angles all congruent? Looking at all four of those angles, they don't look congruent. We've got small angle and big angle there, so probably not congruent. But the big part of this is we do not see a symbol on each of those angles to show that they are congruent. So this is non-regular. All right. This one, we don't know anything about the sides, but we do know that the angles are all different. So this one is also non-regular. You might want to take a moment to see if you can find out what angle B is, and you can find out what angle B is and answer this question in a slightly different way. All right, take a look at this one. Are all the sides congruent? Definitely not. We've got 12, 10, 6 for each of the sides, so this is non-regular. Okay, what about this one? Well, it looks regular. It looks like all these are congruent, and it looks like it has congruent angles, but notice that the symbols are not there. So we cannot just assume that they are congruent because they look congruent. This one we would say non-regular. But if we had more information, like the congruency symbols, maybe it would be regular. What about this one? Congruent sides and congruent angles. So this one is regular. If we take a look at this triangle, same kind of issue as this one. It looks regular, but we don't have any symbols to show. So we would say that this is non-regular. All right, got through all of those. So it says create all the markings necessary to show that these are regular. Pretty simple to go through. In order for them to be regular, you have to have all congruent sides. I got all those congruent sides, and you have to have all congruent angles. So showing all of these, that would be a regular shape. If I'm looking at this square, a regular quadrilateral is going to be a square. So I can show right angles there. That's good. We got a regular square. Now this one is an example of a badly drawn regular figure, but we're going to show that it's a regular figure. We have our congruency symbols for all the sides. Even though the sides don't look like they're the same, the congruency symbol shows it. And then I can go ahead and draw all the congruent angles. I prefer to have the notches in some of them. That's what makes this a regular polygon, even if it's badly drawn. But if you accurately draw these polygons, then you get some really cool results. Notice how this has 5 sides, and this is a regular polygon. This one has 4 sides. It is a square. This one has 5 sides and starting to look a little bit more circular. This one has 6 sides. It's even a little bit more circular. This one has, I believe, 10 sides, and it is looking very much like a circle. And that's one thing that's really cool about a regular polygon. As you increase the number of sides of a regular polygon, it begins to look more and more like a circle. Here's the circle for this one, and notice how close it is to a circle. There's only a little bit of space in the circle that this hasn't taken up, right here, 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 here. Okay? So, for this one, we would show that all the sides are congruent. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And all the angles are congruent. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all the sides and all the angles are congruent. All right. What's the difference between a regular and a non-regular polygon? We've already discussed this, but we want to write it down. A regular polygon, okay, and let's make sure we get this written out. In a regular polygon, all sides are congruent and all angles are congruent. Okay? Both of those have to be true. In a non-regular polygon, okay, in a non-regular polygon, not all sides or all angles are congruent. If you've got one angle or two angles that are not congruent, two sides that are not congruent, then automatically this makes it not a regular polygon. All right, let's go ahead and turn the page, go on to our next set of problems. Find the measure of the sum of the exterior angles for a polygon. So this brings to mind our theorem for the sum of exterior angles of a polygon. I like to call it the EAT, E-A-T, or EAST, E-A-S-T, the exterior angle sum theorem. And that is the sum of exterior angles in any polygon is 360 degrees. All right, so that makes this pretty easy. If I got a rectangle, that's 4 sides, so 360 degrees. If I have a triangle, that's 3 sides, still 360 degrees, using the EAST or the EAT. All right, for a pentagon, that's 5 sides, still 360 degrees. So for each shape, we have 360 degrees as the sum. Let's go ahead and apply that here. I know that this is a 4-sided shape. That's great. But I also know that the sum of the exterior angles is going to be 360 degrees. So I know 70 plus 50 plus 112 plus y is 360 degrees. So I can go ahead and create an equation to solve this, and I can just be like 360 minus 70 minus 50 minus 112, enter, is 128 degrees. Now, I want to communicate how I know this answer. Notice how right now all I have is an answer because I did it in a calculator. Just want to communicate how I know this answer. So I can write down EAST, or I could write down EAT. Both of them are acronyms to help us remember that the sum of the exterior angles is 360 degrees. If I wanted to go a little bit further, I could show that. I could be like, oh, y plus 112 plus 70 plus 50 is equal to 360 degrees. I want to communicate as much as I can, and that's what this does. All right, what about this problem? Oh, same kind of thing. I know from the east or the eat that they sum to 360 degrees. So I know 101 plus 44 plus 69 plus 76 plus 5x plus 20 is equal to 360 degrees, or 360. And I just want to solve for x. In order to do that, I need to do some subtraction here. 360 minus 101 minus 44 minus 69 minus 76 minus 20. I got 50 degrees. So I subtracted each of these parts. This, and this. So I know that 5x is equal to 50. Divide both sides by 5, and x is equal to 10. So I can solve for x knowing that it's 10 degrees. X is equal to 10 degrees. And then I can plug it in to actually find out the length of that angle, or the size of that missing angle. 10 times 5 is 50, plus 20 is 70 degrees in total. So I know what x is, and now I know what that angle is. All right. Looking at this one, same kind of idea. 360 minus 70 is 290, minus 60 is 230, minus 40 is 210, and then minus 65 is 145, I believe. So y is 145 degrees. Now I did all of that in my head. How do I communicate my reasoning? Just put east up there, or eat. E-A-S-T. The idea is to explain how you got it. You don't have to write out a long, detailed aspect to it. Just write out some quick information. Ooh, for this one, same kind of thing. I'll do this in a calculator. We have 360 minus 74 minus 50 minus 98 minus 134 minus 48. Did I do that all correctly? 50. Oh, I made a mistake. And this is what it can happen sometimes, especially with that 134 degrees. Notice how that is not an exterior angle. The exterior angle's out here. So how do I get that exterior angle? Well, I know that my interior and my exterior angle combine to give 180 degrees. They are a linear pair. So I got 134 degrees plus whatever that is. That is actually, I believe, 56 degrees. Is that right? 46 degrees. 134. Oh, clear. 134 plus 46. 180. There we go. So in looking at this, I can go ahead and solve for my missing angle properly now. 360 minus 74 minus 50 minus 98 minus 46 minus 48. All right, and I know that B is 44 degrees. All right. With that knowledge, we can go ahead and answer the next set of questions. Given the measure of one exterior angle on a regular polygon, how many sides does the polygon have? Ooh, this is a good question because I know that the sum of all of them have to be 360 degrees. So we know that the sum is 360 degrees. But In order to get the measure of an exterior angle, we're going to take however many sides that figure has and divide it by, or divide 360 by it to get one exterior angle. So if I take 360 divided by n, where n is the number of sides, I get my exterior angle of a regular polygon. Okay, so since instead of knowing instead of knowing what n is, I know what my exterior angle is, I can use this to solve for n, and we'll see that with the first problem. I've got 360 degrees divided by n is equal to 12 degrees. So how do I solve for n? Well, the process of solving is going to be very similar in each of these, but I want us to see it piece by piece here. In this case, I need to get n out of the denominator, so I'm going to multiply this side by n and this side. What ends up happening is that cancels, so we end up with this new equation. 360 degrees is equal to 12n, or 12 degrees times n. And then I'm going to go ahead and divide both sides by 12 degrees. Notice how a few things cancel here. First, the degrees cancel, and the 12 cancels, and we end up with 360 divided by 12 is equal to n. That'll give us the number of sides. Ultimately, notice what happened to this equation. The 12 and the n just cancel, or just switch places, I should say. The 12 and the n switch places to the other side. Now I'm going to just use a calculator real quick. What is 360 divided by 12? Divided by 12. 30 degrees. So, or not 30 degrees, n is equal to 30. So this polygon is going to have 30 sides. What if it has 45 degrees? Well, I know that 360 degrees divided by n is equal to 45 degrees. Switching it around, 360 degrees divided by 45 degrees is equal to n. N is equal to 8. All right, what if it's 18? Ooh, I know if it's 45 degrees, it's 8. If it's 12 degrees, it's 30. So if it's 18, it's got to be somewhere in between those. I'm going to make a guess, and I'm going to say maybe 15 or 20. Let's go ahead and find out. Rather than write the whole thing, I understand the pattern now, so I'm going to do 360 degrees divided by 18 is n. 360 divided by 18, 18 is half of 36, so this is going to be 20. So it's 20 sides. Yeah. All right, what if it's 14? Well, we know it's got to be more than 20 sides, and it's got to be less than 30 sides, because 12 degrees is 30 sides, and 18 degrees is 20 sides. I'm going to go with, let's say, 25 sides. Let's see how well that works. What is 360 degrees divided by 14.4 degrees? That'll tell me how many sides the shape has. 360 divided by 14.4. 25. Hey, look at that. 20, not degrees. Did that one wrong. But it'll be 25 sides. So we're able to get the number of sides of a regular polygon. Now there is one other thing I want to mention here, and that is this, our n. And I want to make a statement here so we know what n is. N is the number of sides. All right, we're all set. Turn the page. And now we've got our finding the sum of interior angles of a polygon. So here's a polygon. What's the sum of the interior angles? Ooh, this, just like the last one was the East theorem, this is the IAST, or we could call it the IAT. height. Okay, the interior angle sum theorem, or the interior angle theorem, is a little bit easier to write. I don't know, the S just kind of messes things up, probably because I write it like a 5. Okay, and the sum of interior angles in a polygon, and I wrote polygon wrong, P-O-L-Y-gon, is 180 times n minus 2, where n is the number of sides. All right, so if I come over here, I know that this object has 1, 2, 3, 4, 5, 6 sides. So n is equal to 6. This one, n is equal to 5. What about this one? 1, 2, 3, 4, 5, 6, 7, 8, 9. N is equal to 9. So all I got to do is use the formula, 180 times 6 minus 2. And that's 180 times 4, which is 720, I believe. 720 degrees. Here n is 5, so I could use the same formula. And instead of using the same formula, I want to see the other way that we can calculate it. Let's say you forget the formula. Remember how the interior angle sum theorem just looks at how many triangles you can make by breaking the figure up, because triangles make up every polygon. So if I look at this figure, I can break it up into 1, 2, 3 triangles. Each triangle has a sum of 180 degrees. 180. Now, notice how my lines that I made the triangles with do not intersect in the middle of the figure. I could not do this one. Could not go over here and then over here, because that makes an extra 360 degrees. This one works better because they're all angles of the bigger figure. Ultimately, I've got 3 triangles. Notice how the n minus 2 is really the number of triangles that are created. Since I've got 3 triangles, that's 180 times 3. 180 times 3. And 180 times 3 is, I believe, 54 or 540 degrees. All right, what about this one? Just use that formula real quick. 180 degrees times 9 minus 2, that's times 7. And in my head, I can't do that right now. So 180 times 9 minus 2. I could have just put times 7, but I just want to see the whole formula. 1260 degrees. Oh, that was not what I wanted. Might notice that I'm doing this while I'm not feeling too well. In this one, I want to find the missing angle. So in order to get angle Z, I know that the sum of my interior angles is equal to that formula. So I know that n, or how many sides a figure has, is, it won't let me select it with the calculator there. That's getting a little annoying. Okay, maybe that'll be better. Yeah. Okay, so we've got 1, 2, 3, 4, 5, 6, 7. N is equal to 7, so that's 180 degrees times 5. And 180 times 5, that is 900 if I'm not mistaken, correct? Let me just double check that. 180 times 5. 180 times 5. 900. So that is 900 degrees, and then I've just got to I know that the sum is 900, so in order to get this one, I can just subtract out each of those. So I'm just going to go ahead and take my previous answer, that 900, minus, and I'll start right next to the z, the 120 or the 115, minus 155, minus 170, minus 95, minus 110, minus 125. 130 degrees. 130 degrees. Now, I also want to communicate how I got that answer using the theorem. So I'm going to put IAT. All right, next one. Taking a look at this one, this is a five-sided figure. I know that the five-sided figure has to be 540 degrees, so I'm going to put IAT, and I know that x is equal to 540 minus 120 minus 110 minus 110 minus 120. And you notice how it's subtracting 110 twice and 120 twice. So I can do that like this. 540 minus 120 times 2 minus 110 times 2. Oh, it did. There we go, times 2. Enter. And plus 540, because I didn't do the 540 at the end. So the top one is 120. X is equal to 120 degrees. All right, that's looking great. What about this problem? Hey, look at that. This is a four-sided figure, 1, 2, 3, 4, and so I know that it sums to 360 using the IAST. And notice how I'm using different acronyms based on, you guys might change it. It's fine to describe it on your own, but the idea is to communicate how you know. 360 minus 45 minus 88 minus 70. 360 minus 45 minus 88 minus 70. Enter. X is 157 degrees. All right, looking at this one, I want to find out what angle B is. Remember on that problem on the previous page, I said it'd be a good idea to find angle B. If you already did, you'll know the answer to this. So there is one thing for me to note. I've got this angle here, and I don't want to forget it, so I'm going to write the actual degree. I know that that's a right angle, so it's 90 degrees. How many sides does this have? 1, 2, 3, 4, 5, 6, 7. It's got 7 sides, so I know that that's 180 times 5, and I think it's 900. And now I'm going to subtract out all the other angles. 148 minus 90 minus 142 minus 130 minus, I put a plus, minus 129 minus 120. That's a total of 141 degrees. All right, and I know that that's 141 because of the IAT. All right, here's one more. This one we probably want to solve for x. We know that that's 90 degrees. Looking at this, we know 1, 2, 3, 4, 5, 6. There are 6 of them, so that would be 180 times 4, which should be 720. 180 times, and I'm going to use the whole formula, 6 minus 2. Okay, there's 180 times 6 minus 2. And then I'm going to subtract out the other ones. Minus 134, minus 160, minus 126, and minus 90. So I got 210. That's for the sum of these two angles, though. So I'm going to actually write that out. 5x plus 5x equals 210. Maybe make it a little smaller, and is there a way to bring it down? All right, there we go. 210. So adding these together, we know that 10x is equal to 210, or x is equal to 21 degrees. Since x is 21 degrees, 5 times 21 gives us the measure of those angles. 105. 105 degrees. All right. Get that back out of the way. And suppose that angle 1 and angle 3 are congruent. The measure of angle 1 hold on, let's add this detail. Angle 1 and angle 3 are congruent. The measure of angle 1 is 3x, so that's 3x there, and the measure of angle 2 is 2x. So I've got those written down. It says, what is the measure of each exterior angle? So I want to know the measure of every single exterior angle here. 1, 2, 3, 4, and 5. So in order to answer this, I'm going to go over here and kind of make my answer list. The measure of angle 1, measure of angle 2, measure of angle 3, measure of angle 4, measure of angle 5. Now, as I'm going through this, make sure you've already got some of these answers down. Some of them are pretty clear and easy right at the beginning. Knowing the 5 and the 4 are right next to these right angles, they're a linear pair with those right angles. So I automatically know that those are 90 degrees. They're right angles themselves. So what else do I know? Oh, these are exterior angles, right? So that means I'm going to use the exterior angle sum theorem. All right, so I know that they're all going to add up to, how many sides does this have? 1, 2, 3, 4, 5. 5 sides, that's 180 times 5 minus 2, which is 540. All right, so we know it's going to sum to 540. We know that angle 5 and 4 are 90 degrees, so I can just go 540 minus 90 to get rid of those two angles. And then I'm going to go ahead and subtract out 3x, 2x, and 3x. And all of that's going to add together to get 0. But that's not necessarily a big problem. I know that I can subtract those two 90s from 540. That becomes 450 and then 360. So I know that 360 is equal to 3x plus 2x plus 3x. Adding those together, 360 is equal to 8x. And dividing both sides by 8, I know that 45 degrees is equal to x. I believe that's correct. Let me just double check my math over here. Sometimes our math's just off. How do I stretch this out a little bit? There we go. So 180 times 5. Sorry, got to fix that whole thing. Delete that one. Times 5 minus 2. Okay, so I've got that first part, and then that gives us the 540, and then I'm going to subtract 180. That gives us the 360, and then I'm going to divide by 8. And I got 45 degrees is equal to x. Well, that's great. That means that this angle 2 has to be 90 degrees. Because x is 90 degrees. Let me just make sure. This feels off a little bit. 1, 2, 3, 4, 5. Oh, did you guys notice my problem? I made a mistake. All of these were interior angle sum theorem, and so you had to do the 180. This is the exterior angle sum theorem. So I was using the wrong formula to start out. If you use the wrong formula, you're recognizing what you need to do. And notice how I use the proper statement up here. I know what I was supposed to use, but then I used the wrong formula. Well, that's okay. I'm just going to come over here and correct it. I'm going to know that this stuff isn't good because it used the IAT or IAST. Okay. So instead, I'm going to come over here and I'm going to change it up and use the EAST. So I know that all my angles have to sum to 360 degrees, not 540. And the same idea applies. I know that 3x plus 2x plus 3x plus those two 90s, 2 times 90 degrees is equal to 360. So that tells me that 8x is equal to 180 degrees, or x is equal to 22.5 5 degrees. Okay, so if x is 22.5 degrees, what does that tell us? Now, one of the ways that I noticed that it was wrong, and I want to point that out right here, is because of this. It said 90 degrees, and that definitely is not a 90-degree angle. Our answer should be pretty reasonable. If your answer is not reasonable, that might be a show that you're doing something a little bit off. All right, 45 degrees. Now, it could be that the person who drew it's just a bad artist, but we probably wouldn't do that to you on a test, because 2 times 22 is 45 degrees, or 2 times 22.5. 3 times 22.5 is going to be 67.5 degrees. 67.5 degrees. All right. Looking at our next page, and I believe this is the final page of our work. We're going to finish things up. So, match each equation with what it finds in a polygon. Sum of interior angles in a polygon, boom, 180 times n minus 2. Sum of exterior angles does equal 360. And one interior angle in a regular polygon is the n minus 2 times 180. But then we divide it by the number of sides, because every side, every angle is going to have the same degree. All right. Which equations would represent a formula for finding the sum of interior angles of any polygon? Ooh, this one is pretty good. We know that it's going to be this one, but is there another way to write that? Definitely. It's kind of easy to see it here, but we could distribute the 180 to both terms. So it becomes 180n minus 2 times 180, which is 360. So if I come over here, I can see that this one, the one right next to it, is the same. Now, the one over here on the end, this is that special one. This works for a regular polygon. And it's not something you're required to memorize or anything like that. This one you're required to memorize for sure. This one you're not necessarily required to, but it's a good idea to learn how to do it and make sure you understand. All right. Which hexagon below represents the formula for finding the sum of the interior angles, or best represents it? Now, if I take a look, this is a hexagon, so how many triangles should it be broken into? If you thought of 4, you're correct. So if I look here, 1, 2, 3, 4. Perfect. This one breaks into 1, 2, 3, 4, 5, 6 triangles. But notice how these triangles kind of intersect a little bit in the middle. They're not a full intersection because they're different triangles, but that adds an extra 360 degrees to our total. And since there are 6 triangles, that's an extra 180 and another 180 to get 360 degrees. This is the one that best represents the 180 times n minus 2. So I'm going to go ahead and circle that one. Okay. And we know it breaks into 4 triangles. All right, it breaks into 4 triangles. All right, what's the best name for this quadrilateral? Provide reasoning for your answer. Now remember all the quadrilaterals that we talked about. I'm going to write them out right here so we remember what they are. The first one is just a basic quadrilateral. Quadrilateral. Okay, the quadrilateral's got 4 sides. Then there's a kite. That's got some special properties, specifically one diagonal bisects the other and consecutive sides are congruent. Then there's a trapezoid. Okay, and the trapezoid is where there is exactly one set of parallel sides. Then we have the parallelogram. After the parallelogram has 2 sets of parallel sides. After the parallelogram, we have the rectangle. A rectangle is a parallelogram, but it also has some extra requirements. Specifically, all 4 angles should be 90 degrees. Now, there are some other properties, but that's the one we're going to talk about. Then there's a rhombus. Okay, so we've got the rectangle, we've got the rhombus. After the rectangle and the rhombus, we have the isosceles trapezoid. And then finally, we have the square. And the square is both a rectangle and a rhombus. So we have all of those. Which one is this? Well, in looking at it, how can I find out? If I look at this, I know that I've got a length here and a length here. This goes over 1 and down 2. So if I were to use the Pythagorean theorem to get my third side, I could do that. I could use what's also called the distance formula to do it, but ultimately that distance formula is the Pythagorean theorem. So I know that the square root of 1 squared plus 2 squared is equal to, let me get rid of that square root going so long, 1 squared plus 2 squared. That's equal to the square root of 5. So I know that that's the square root of 5. But wait, this one's a 1 by 2 as well. This one's a 1 by 2 as well. This one's a 1 by 2 as well. So I know that all of these are the square root of 5 because they all share the same slope triangle. All 4 sides have the same slope. Triangle. Okay, all 4 sides have that same slope triangle. Oh, well, that's kind of nice. We got the square root of 5 for each one. That means all 4 sides are congruent. So it's a polygon where all 4 sides are congruent. Quadrilateral where all 4 sides are congruent. Let's take a look at the diagonals. Here's a diagonal. Here's a diagonal. Wait a second. Those diagonals are perpendicular. One is horizontal, one is vertical. But they also break each other into pieces. Those are the same length, and these are the same length. So the diagonals bisect each other. Oh, diagonals bisecting each other imply that it's a parallelogram. So I'm going to write down the properties that I see. We have 4 congruent sides. We know that the diagonals are perpendicular, and we know that the diagonals are or bisect each other. That's pretty good. I know a lot of stuff. So knowing that the diagonals bisect each other, that makes it a parallelogram. Knowing that the diagonals are perpendicular, it could be a rhombus or a kite. Knowing that it's got 4 congruent sides, that makes it not a kite. It's got to be a rhombus. So I'm using the properties to determine what shape it is. Altogether, I know that this is a rhombus. So let me go ahead and write that in here. The shape is a rhombus because it has 4 congruent sides, perpendicular bisectors, and I forgot what the third property was, and the diagonals bisect each other. There we go. All right, with that said, we have finished our entire scrimmage or review. I like to call them review, but we've been calling them scrimmages as well. I hope you guys have a wonderful day, and this is helpful to you to get ready for the test tomorrow. Bye-bye.